ready to pay attention? You've had enough? Dave, bala undagada. Now listen, okay? What? If I have two, if I have two vectors A and B, all right, which are oriented in some fashion, what is the maximum value of mod of A plus B? What is the maximum value of mod of A plus B? Mod A plus mod B. When does this condition happen? When the angle between A and B is 0, right? What is the minimum value of mod of A plus B? Mod of A plus B has to be greater than or equal to mod of mod A minus mod B, right? Where did these inequalities come from? So let me ask you a question. If I have three vectors which form sides of a triangle, all right? This is vector A, this is vector B, this is vector C. What can you say about these three vectors? Can you say something about the moduli of these vectors? About the moduli of these vectors, can you tell me some inequality between the moduli of these vectors? So in this particular case, where the angle between the vectors is non-zero, right? Mod C is less than mod A plus mod B. So you have heard this before, that in any triangle, or for three lines to form a triangle, the sum of lengths of two sides should be greater than the third side. The sum of lengths of any two sides should be greater than the third side. So is it obvious to you why? So what is displacement? You have learned in lower classes what displacement is. It is the shortest distance between any 2 points, right? Any other path other than the shortest distance, you would have to go through a longer distance, right? So C vector is the shortest distance. So this going from this point, let this point be P, Q, R. C vector is going directly from P to R. If you have a detour in the beginning where you first go to Q and then go to R, the path will have to be longer, right? So in any triangle, sum of any two sides should be greater than the third side. Based on that, if I were to ask you, is it possible for three vectors of magnitude 20? Okay. Is it possible for three vectors of magnitude 20, 9 and 15 to add up to 0? Is it possible for three vectors of magnitude 20, 9 and 15 to add up to 0? Three vectors of 20, 9 and 15 to add up to 0? Yes or no? Yes or no? So why do you feel that it is not the case? It is possible, it is possible for these three vectors to add up to 0, because it is possible to create a triangle whose sides are 20, 9 and 15, right? It is possible for these three vectors to add up to 0. The angle is not 90 by the way. It is possible for three vectors of these magnitudes to add up to 0, because if you take any one side, it is less than the sum of the remaining two sides, right? But if I were to give you something like, instead of 20, I give you 25. Vectors of magnitude 25, 9 and 15. Is it possible for them to add up to 0? No, right? Correct. Because 9 plus 15 is 24, which is less than 25. Okay. So this inequality you know now. You will be able to do most of the problems, in all of the problems, in addition, subtraction and resolution, right? Okay. Now we will go on to a different topic, well, an extension of the same topic, which is multiplication of vectors, right? So you know what happens when you multiply a vector with a scalar, correct? What happens when you multiply a vector with a scalar? Okay, I know what was intended. I know what was intended, but the magnitude of the vector changes. If you multiply of a scalar of magnitude 2 with a vector of magnitude 2, the vector will lengthen, right? The vector will lengthen, shorten, or clowns. The vector will lengthen, shorten, or change direction entirely. If you multiply by a scalar which is negative, the direction of the vector will change by 180 degrees, right? So the direction of the vector will reverse if you multiply with a scalar that is negative. So you are already clear about scalar multiplication. So to test you, if I were to give you 3i plus 2j minus 4k and ask you to multiply it by 3, what are you going to get? Yes, excellent. Now we go on to vector multiplication. Okay? So vector multiplication, there are two kinds. Now listen carefully. Vector multiplication, there are two kinds. There is the scalar multiplication. There is the, scalar product. Scalar product or dot product, and then there is the vector product or cross product. So you have, so why do we have two different kinds of multiplication for vectors? It is one of the demands made by physics, right? We want that in certain cases, two vectors when multiplied should give a scalar. We want in other cases, two vectors when multiplied should give a vector. So can you give me an example of a place where we use dot product or scalar product, where we need two vectors, their product to be a scalar? Work done. We want the product of displacement and force to give us a what? Scalar, right? Which is work. That is one situation. Where do we need a product of two vectors to give us a vector? The same situation, we need to multiply displacement and force to get a vector in the case of torque, right? Are you familiar with what torque is? Negative arm. Work done will be negative. So you will learn what torque is along the way, but it is the vector product of force and displacement, right? Yes? Moment of a force, yeah. Yeah. Yeah, there are a moment of a lot of things. There is moment of inertia, which is the analog of mass in rotational dynamics. There is moment of force, there is moment of momentum, there is a lot of things. Okay. So, dot product, dot product is written as A vector dot B vector. It is represented by a dot. Do not put the multiplication sign or a bracket like this. If you write something like this, A into B, this is wrong. Okay? It is represented as A dot B and read as A dot B. Okay? So A dot B is equal to mod A mod B into cos theta, right? So this is a scalar quantity. This is the modulus of A times the modulus of B times cos theta, where theta is the angle between the two vectors. How do you find the angle between the two vectors? You have to join the vectors at their tails, right? You have to join the vectors at their tails and take the smallest angle between them. That is going to give you the angle between the two vectors, correct? Okay, so let's dive into a question. Very simple question. If I have this having a magnitude of 3 units and this having a magnitude of 5 units, and the angle between the two vectors is 30 degrees, what is A dot B? What is the dot product of the two vectors? 15 root 3 by 2, right? Simple enough? So can you give me a geometric interpretation of dot product? Huh? The vector? No. So if you have two vectors, this is say vector A and this is vector B. What is A cos theta? What is A cos theta? What is mod A cos theta, by the way? This is mod A mod B cos theta, right? What is mod A cos theta here in this diagram? It is the component of A along B, right? It is the projection of A on B. You learned how to resolve vectors, is that right? When you resolve vectors along the adjacent sides, you get A cos theta. This much is A cos theta. So dot product is the scalar product, or is the product of the component of one vector along the other with the other vector, right? Dot product is the product of the component of one vector along the other multiplied by the other vector. That is dot product. And if you take it the other way around, if you consider B cos theta first, you get the same thing. So this distance is going to be B cos theta. This distance is going to be B cos theta, and you are going to have the dot product to be B cos theta times A, right? Which is the component of B along A multiplied by A. The component of one vector along the other multiplied by the modulus of the other vector is your geometric interpretation of the dot dot product of two vectors, correct? Yes. The, the product of the component of A along B, the product of the component of A along B the product of the component of A along B with the magnitude of B is the dot product A dot B. The product of the component of A along B with the magnitude of B is the dot product of A and B. The product of the component of A along B with the magnitude of B is called the dot product of A and B. Huh? So here I have taken A vector like this and B vector like this, right? So to find the component of A along B, I have to drop a perpendicular from A onto B. This is the component of A along B, correct? The component of A along B, which is mod A cos theta, times the magnitude of B, which is mod A mod B cos theta, is the scalar product. So you can take it in the opposite way as well. So I used the same color for the opposite way, which is why you are getting confused. So to find the magnitude of B along A, you drop a perpendicular like this, and this magnitude is B cos theta. To resolve a vector, that vector should always be the hypotenuse of the triangle, right? So this magnitude is B cos theta times the magnitude of A will give the dot product. Clear? You have a doubt? Okay. Okay. Now, we learn some properties of the scalar product, okay? The first thing is that B dot A is equal to A dot B, right? The commutative property. Any problem? No? Okay. So what is A dot A? Any idea? What is A dot A? What? Not mod of A, not just mod of A. What is it? A dot A is mod of A square. What is cos 0? Why? Because if you take the same vector twice, if you take the dot product of the same vector, both vectors are going to have the same direction, right? The angle between them is going to be 0, correct? So you are going to have mod A into cos 0, which is cos 0, which is 1, correct? So you are going to get mod A square. There is one more property which is distributive with respect to addition, right? It is that A dot B vector plus C vector. This is the vector addition of B and C is going to be equal to A dot B plus A dot C. Correct? What can you conclude if I tell you, don't talk please, what can you conclude if I tell you that A dot B equal to 0? So if I tell you that if two real numbers x and y multiplied together gives 0, then either x equal to 0 or y equal to 0, right? So the same condition applies here. A dot B is mod A mod B cos theta, right? Either A is a null vector or B is a null vector. But there is one more condition. Hmm? Or theta is equal to pi by 2. Did I teach you how radians works? 90 degrees? Right? Don't worry about pi by 2. Just write down 90. The condition works the other way around as well. Right? If A vector is perpendicular to B vector, then A dot B will be equal to 0. And if A dot B equal to 0, then either mod A is 0 or mod B is 0 or cos theta is 0. Right? Theta is 90. What can you say if I tell you that A dot B is less than 0? Huh? Yes, A dot B will be negative, but theta is greater than pi by 2. ഏത് ഇതോ സൂപ്പറോ this is 0. What can you say if A dot B is less than 0? It means theta is greater than 90. Which clown said that? How will mod of a vector be less than 0? Get your doubts out. Okay. Less than 0. If A dot B is less than 0, mod A and mod B cannot be less than 0. Mod A and mod B cannot be less than 0. Mod A is the length of the vector, right? The length of the vector cannot be less than 0. So mod A mod B cannot be less than 0. The only thing that can be less than 0 is cos theta. If cos theta less than 0, it means theta is greater than 90. Correct? Okay, clowns, take. How do you find the dot product of two vectors if it is given to you in terms of I, j, k components? How do you find the dot product of two vectors if it's given to you in terms of I, j, k components? So, if it is given to you in terms of I, j and k, you have to use this property, right? You have to use this property. So I will show you in a second. Okay. What is I dot I? What is I dot I? I dot I. Hey, listen. I dot I is 1 into cos 0, right? Which is equal to 1. What is j dot j? 1 into 1 into cos 0 again, which is equal to 1. Right? Hold on, Raja. What is k dot k? This is also equal to 1. Yes? But what about I dot j? What about I dot j? So I dot j is 1 into cos 90, which is equal to 0, which is equal to j dot I, right? What is I dot k equal to? 0, which is equal to k dot I also, right? So what is j dot k? This is also equal to 0, which is equal to k dot j, right? Hey, Aniki, Ninte Peranda, what is your name? No, not you, him. Indrajit. Indratir. Yeah, okay. Stand up. Stay standing. Can you cooperate? Okay. So imagine I am giving you two vectors, which is ax I cap plus ay j cap plus az k cap, and I am taking the dot product with, who is asking? Because I and j are mutually perpendicular. I, j, k are mutually perpendicular. The x-axis, y-axis, z-axis are mutually perpendicular. So this is I, this is j, and this is k. They're all 90. This is k. They're all 90. Look, look at that corner. Look at that corner. All the angles are 90, right? The corner has edges. The edges are x, y, and z. Good question. You there? Tell me, first of all, this is not Indu, right? This is dot. Tell me what is I dot j dot k. That is one answer. Is it zero? Any other answers? It's not zero. Alok, what is I dot j dot k? It's not zero. No, it's not one. It is not defined. This is a scalar. Clowns, listen. J dot k is a scalar, right? Eh? When did we?
No.
It would be not defined. J dot k is a scalar. You are trying to take dot product.
J dot k is 0. So I dot 0 is 0.
You cannot multiply 0 with dot.
Date. Did you understand how this comes about? J dot k is a scalar. You cannot take dot product of a scalar and a vector. You can only take dot product of two vectors. Right? Did you understand? Because it is a dot product, right? Dot product always returns a scalar. Yes. These are vectors. This is a vector, this is a vector. The resultant is a scalar. So were you not following that? I said very, very expressively that you get scalars when you take dot product.
So according to theta, this vector into vector theta.
Yes.
When I say 3k vector, that is cross product between scalar.
No, that is scalar multiplication.
No, but that is a vector that you are saying, right? If I have a k vector,
So you can have scalar multiplication, dot product, and cross product.
it's the same thing, right?
That's scalar multiplication. That's fine, but that's scalar multiplication, not dot product.
Can I sit?
No, you keep standing. Stand up. Listen, clowns. Is this legal? What is the answer to that? Not zero. Null vector. Nah, hello. Stand up.
But I don't get big disturbance.
This is null vector. Right. Because you are multiplying the scalar value, which is I dot j, times the k vector. Right. You are multiplying a scalar value times the k vector, you get the null vector. But if I were to put dot here, it will become not defined. You understand? Clear? To show that they are a unit vector of magnitude 1. നിന്ന് ബഹളം ഉണ്ടാക്കാവാ. മിണ്ടരുത്. Stand up. Doesn't make much difference, but yeah, stand up. Listen, let's get ahead with the class. Okay, if I have a vector which is ax I cap plus ay j cap plus az k cap, and I take the product with bx I cap plus by j cap plus bz k cap, what am I going to get? Yes? Tell me. So you have to use, so you have to use this particular identity, right? So this is essentially going to be ax I cap, ax I cap, wait, ax I cap times bx I cap. What is it? Ax bx, right? What is ax I cap times by j cap? 0, correct? What is ax I cap times bz k cap? 0. So did you get the pattern? This is going to be equal to ax bx plus ay by plus az bz. Okay, since you guys are in a fun mood, I'll give you a problem, okay, which is unrelated to this. So if I have, this is a maths problem, okay, this is a maths problem. If any of you solve it first, you get to sit down. Any one of you solves it, they get to sit down, okay. If somebody else solves it, all of you remain standing. So listen, listen, if I have 6 numbers, 6 real numbers, a1, b1, a2, b2, yeah sure, a3, b3, I have 6 real numbers, alright. I want you to prove that a1 b1 plus a2 b2 plus a3 b3 the whole square is going to be less than or equal to a1 square plus a2 square plus a3 square into b1 square plus b2 square plus b3 square. See if you can prove this. Sure enough, good enough. But this has to be true. A square plus b square plus c square plus ab plus bc plus ca. 2ab?
Yeah.
Yeah, yeah. Yes?
അതെ അതാ ഞാൻ ചെയ്യുന്നത് ഓട്ടോമാറ്റിക്കലി ആവൂലേ ഇതിന്റെ ഓബിയസ്
How do you prove this?
Common sense.
Give me a mathematical way to prove it.
Sir, expand the LHS, then you will find out for yourself.
Remember that there is this square here. Huh? You can assume a value, you can check.
Sir, that will all come in the form of
Huh?
ഞാനേ ഞാൻ ചെയ്തിട്ട് കാണിക്കാം
No, these are all random numbers. These are 6 random numbers.
ഇതിലേക്ക് ആവശ്യം
You can solve it by any method, hook or crook. Why are you sitting? It doesn't make much difference, but still I insist you stand.
70 short man
You're what? No, you remain standing. You sit when you solve it. Solve it.
and IQ too high
Isn't it obvious that you can apparently, multiply the arches, the things in the arches, and you can actually write it like this, the whole square. No, I haven't written as much, but I can say that, if I multiply those two brackets in the arches, then the whole
You
square.
need it to be less than a1 square plus a2 square plus a3 square into b1 square plus
But
b2
it will
square.
be equivalent to the LHS, right? Still,
No,
you have to make it
less.
less.
So I lied when I said it's unrelated. That's the first hint.
Liar, liar, pants on fire.
what is that
I think I got it, but if we take the two vectors and if we multiply the magnitudes of it, okay, I'm lost. I
sir
think I'm stupid.
we will put these six values as as vectors and then from there when you do the multiplication anytime it goes like answer
Do you want a hint?
yes 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 yes
Why are you sitting down? The equality does not change. Right.
He included both sides.
and it's still less than that
If we take two vectors and if we just multiply the magnitudes, we'll get some bullshit value, okay? And if we take the cross product and cross product, the maximum value it can get is cos 1. It can't exceed 1, but
Yes.
I got to correct it. Is that the answer?
Yes. Sit down. Hello. So we take these numbers like this. We take A1 I cap plus A2 J cap plus A3 K cap, right? We define, a clowns, we define two vectors. Remember, A1, B1, A2, B2, A3, B3 are real numbers. We define two vectors, A1 I cap plus A2 J cap plus A3 K cap, and we define another vector, B1 I cap plus B2 J cap plus B3 K cap, correct? And we take their dot product. What are we going to get? A3, B3. In other words, you are going to get this, right? So essentially, if you have two vectors, let this be vector A and let this be vector B, okay? A dot B is equal to mod A mod B cos theta, right? Right? Or you have A dot B by mod A mod B is equal to cos theta, which is less than or equal to 1. Cos theta is always less than or equal to 1, correct? Are you aware that cos theta is less than or equal to 1? So A dot B has to be less than or equal to mod A mod B, which is what I have written. Cos theta is less than or equal to 1, yeah.
Yeah, you lied to us. Yeah, you told they are real numbers.
These are real numbers. These are real numbers. I have defined a vector. Get up. I said get up. I have defined a vector using these real numbers. When I say that for a vector A1 I cap plus B2 A2 J cap plus A3 K cap, here A1, A2 and A3 are real numbers. Do you understand? Huh?
Can you write down the example?
Why are you sitting down, man?
I am standing 100. Not for running.
Okay. This A dot B less than or equal to mod A mod B. This is called the Cauchy-Schwarz inequality. The Cauchy-Schwarz, oh sorry. This is the Cauchy-Schwarz inequality. That A dot B, Dave, you there, stand up. Go stand over there.
Stand back point.
Sir,
Huh?
he has to stand up. He, like,
He
sir,
he
like,
talks without irritating me, at least
no,
I
he
think.
is irritating us.
If he is talking, he is doing it without irritating me. I haven't caught him yet. Right.
Eventually caught him.
Catch him.
Catch him, yeah, whatever.
When I do catch him, I'll throw him out.
Innocent until proven guilty.
Okay. So listen. So listen. If I have two vectors, A and B, how do I find out the angle between them?
Cos theta is equal to A by
So if I have two vectors A and B, this is vector A, this is vector B. How do I find the angle theta between the two vectors? I do A dot B by mod A mod B equal to cos theta. Correct? So if I have a vector like this, 3i minus 2j plus 4k, how do I find the angle made by this vector with the x-axis? How do I find the angle made by this vector with the x-axis? To do this, you find the angle made with the I vector, right? With I cap. You find the angle made with I cap, which is going to be 3i minus 2j plus 4k dot I cap divided by under root 9 plus 4 plus 16 into under root 1, right? Or cos theta is going to be equal to 3 by root 29, right? R cos, okay, whatever. Now, you four clowns, why are you standing behind him? I said go stand there. Okay, I will give you a problem, and you also. First one to solve that gets to sit down. If somebody else solves it, all of you remain standing.
Sir, can someone else solve for me by being my representative?
Then he gets to sit down. Yes? So if I have two vectors, the angle between the two vectors cos theta, if the angle between the two vectors is theta, then cos theta equal to A dot B by mod A mod B, right? A dot B is mod A mod B cos theta. So A dot B by mod A mod B is cos theta. So I have done the same thing here. In order to find the angle made by this with the x-axis, I found the angle made by this with the I cap direction, right? So I did the original vector dot I vector divided by the modulus of the original vector divided by the modulus of the I cap vector.
So you use I cap instead of B vector.
Yes, B vector was I cap. That's it.
Okay.
Advait, stand up. Advait, stand up. Yeah. Find all values of A. Find all values of A for which these two vectors are perpendicular.
Find all values of
A for which these two vectors are perpendicular.
are perpendicular.
Yes. A for which these two vectors are perpendicular. A for which these two vectors are perpendicular.
A I cap minus what?
2 j cap plus k cap and 2a I cap plus a j cap minus 4 k cap. Hey clown, stand up. Next time I catch you sitting down, I'll remove you from that place. Allah. Yes, that's right. Were you able to solve? Huh? You told him the answer. Stand up. Eh? This is a sin officially in this class. Battery. No, that is not assault and battery. That is just battery. Stop talking. No. Eh? No. Find all values of A for which these two vectors are perpendicular. What? Eh?
It comes as 1 plus or minus 3 by 2.
Can you solve it on the board? You can solve it on the board. Come here. Okay. Saeed. Eh? Yes. No. Okay, how many of you got the answer to this? Wait. How many of you got the answer to this? You guys did not get? You did not get? None of you got? You clown. What was your name? Arjun. Yeah. Were you able to solve? So what is the condition for these two vectors to be perpendicular? Their dot product should be 0. Right? Their dot product should be 0. What is this? What the hell is that? Yeah, but how did you end up with that? പോയി നിൽക്കണം അവിടെ. Absolute clown. You have, Advait, listen. Hey, you clowns, listen. You have to take the dot product of the two vectors and the dot product has to be equal to 0. Right? So, here, 2a square minus 2a minus 4 should be equal to 0. Can you solve this quadratic? Yes, you can. And yes?
No, we can't do common.
Hmm?
Numbers, if it's like this, it's easy. The numbers are 2 and minus 2 and plus plus 1. So ഇവിടെ minus 2 into 1 is not equal to 8. മനസ്സിലായോ? As in, we have to divide the whole equation by 2, no? അല്ലെങ്കിൽ പറ്റത്തില്ല.
You can use the quadratic formula minus b plus or minus. Two comma minus one, right? Headache, conjunctivitis. What is it? Remain standing. 2 comma minus 1. Bharat, stand up. Yeah, okay, fine. Sit down.
Sir, 2 comma minus 1, 50.
Sit down and shut up. Don't disturb me again. The rest of you keep standing. Yes. ഈ ക്വാഡ്രാറ്റിക് ഇക്വേഷൻ എങ്ങനെ കിട്ടി? ഡോട്ട് പ്രോഡക്റ്റ് എന്തിനെടുത്തു? ഡോട്ട് പ്രോഡക്റ്റ് എന്തിനെടുത്തു? ഡോട്ട് പ്രോഡക്റ്റ് സീറോ ആയാൽ എന്ത് കിട്ടും? What is the use of that? What is the point of dot product being zero? Remain standing. How did this equation come about? How did you get this equation?
Sir, how did you get the equation? I wanted to ask that.
So the dot product of these two vectors has to be zero, because the condition is that they need to be perpendicular. If two vectors are perpendicular, then dot product is always zero. So we found the condition by taking the dot product equal to zero. And for that we got this quadratic in A, which we solved to find the value of A. Remain standing. Can you what? No. Okay, enough. Enough. All of you sit down. Now, if you disturb the class, I'll keep you out. All right? It's getting heavy now. The topic is going to get heavy. How do I find? How do I find? How do I find the vector if I have two vectors? If I have two vectors A and B, right? How do I find the vector which is the component of A along B? Any idea? How do I find the vector which is the component of A along B? So when you resolve a vector, you can resolve it in two directions, right? You resolve it as perpendicular components. So this is going to be the vector of A along B, and this is going to be the component of A perpendicular to B, right? How do you find these two vectors? I want you to find the vector which is the component of A along B, and I want you to find the component of A perpendicular to B. So I will give you values to start with, okay? If I tell you that B is I plus J and A is 3I minus J I need you to find the component of A along B and the component of A perpendicular to B. Who asked what it means? So you know what component is, right? So if I have a vector like this, the component along this direction is when I drop a perpendicular like this, and this length, for example, if this is A and this is theta, this is A cos theta. I want the vector which represents the component, this vector, right? And this is A sin theta, correct? So I want you to find the two vectors. You don't have theta.
So A cos theta, that cos theta is precedence of what we have the dot product by magnitude.
Hmm?
As A cos theta is a component.
Hmm.
So A into A vector dot B vector by mod A mod B.
Will give you cos theta, yeah.
Yes.
But you need,
No, will give you the component.
yes, it will give you the component. You need the vector along the component. You need the vector representing the component.
Ah,
So you have to multiply by b cap.
by B cap. Right.
So I will give you a hint. I will give you a hint to start with. Okay? So what you need essentially is a mod A cos theta b cap, right? What you need is mod A cos theta b cap. Now mod A cos theta can be written as A dot B divided by mod B, right? This can be written as A dot B divided by mod B. You multiply that with B vector. What is that? I asked you to find the vector representing the component. Eh? Could be, could be.
Mod A cancel. So this you will get this as this part, and then B cap is this much.
B cap is what?
1 by root 2 into I plus j.
Yeah.
But then that is the same as B vector. This is equal to B vector.
Could be, could be. What's your final answer? So you're telling me it's essentially just B cap. Not theta and the. So essentially, I have taught you this. Hey, clowns, listen. I have taught you this before. B cap is B vector divided by mod B. What is I plus J? A joke?
Okay, what am I finding? Mod A cos theta B cap, what is that?
That is, you know what is A cos theta?
Huh,
It is the component of A along B.
huh.
You want to find the component vector of A along B. So this is A. Oh, the board locked. Never mind. This length is the component. Yes. I want a vector having the same length like this. Right. I want a vector having the same length like this. That is the component vector of A along B.
So if it was component length along A, then it would be A cap.
Yes, it would be A cap. But it would not be A dot B by mod B. It would be A dot B by mod A.
So
How did I get A dot B by mod A?
AB cos theta. Won't cos theta be sin theta?
Cos theta.
What is a
Sir,
cos theta?
sir,
A dot B by mod A mod B is cos
A
theta.
dot B by
but
mod A mod B.
sir, do you want to
Could
see
be,
the
we'll see.
result of a bright, intelligent student?
അതായത് പെർപെൻഡിക്കുലർ എടുത്തു അതിന് 90 എടുത്തു ഇതിന് cos theta എടുത്തു
I plus J by 3I minus.
Sir,
I like you.
IIT ഉറപ്പല്ലേ?
ITI എന്ന് കേട്ടിട്ടുണ്ടോ? Dave, Narada, what is this? So A dot B is just 3 into 1, 3 minus 1. This is mod of that. This is root 2. No, no. So listen, listen. Clowns, what I need is A dot B by mod B into B cap, right? This is what I need. So what is A dot B? What? A dot B is 2, right? Three I minus J plus K is equal to A. I plus J is equal to B, right? Hey, don't irritate me further. Okay, keep quiet now. What is A dot B? What is A dot B equal to? 3 minus 1 plus 0, which is equal to 2, correct? So what is mod B? Mod B is root 2, right? So what is B vector by mod B? Which is equal to B cap, which is equal to I plus J divided by root 2, right? So now tell me, what is A dot B divided by mod B into B cap? What you have to find is the component of A along B, which is going to be A dot B divided by mod B, B cap. What is this going to be? Simply I plus j, right? So what is given here? What is given here is the component of 3i minus j plus k along I plus j. Right, I have given you the number correctly. Right. But let's say this is 2i plus 2j. What is going to be the value? What is going to be the component of a along 2i plus 2j? You there? What is going to be the component of 3i minus j plus k along 2i plus 2j? Alo, what is it going to be? What is the component of 3i minus j plus k along 2i plus 2j? We just did it. No. Yes? I plus j. Huh? Wait, let me check if everybody followed what I said earlier. Right? Did you follow what I said earlier? If I have two vectors, one of them is A like this, the other one is B like this. Right? The component of A along B will be this particular vector. This particular vector, right? I drop a perpendicular and this vector will be the component of A along B. How do I find that? I need to take mod A cos theta B cap, right? That's it. I need mod A cos theta B cap. Mod A cos theta is the length of the vector, right? Times the direction of B will give the component of A along B, right? Yes? So to find mod A cos theta, I simply do A dot B divided by mod B, right? A dot B is mod A mod B cos theta. I want to get rid of the mod B, so I divide by it, right? Did you follow? This times B cap is the component of A along B. How do you find the component of A perpendicular to B? And don't tell me cross product. How do you find the component of A perpendicular to B? How do you find this component? The magnitude is mod A sin theta, yes, but how do you find it? Huh? Huh? What? No. Why? How did you get that? Cos theta is what? First of all, cos 90 is 0. So, this is not 90. This is not 90. The angle between the two components is 90. That is correct. But the angle between the vector and the component is not 90. How many of you understood the previous step where we found the component adjacent side, component to the adjacent side? So if you understood, raise your hands. You guys didn't follow. because that only represents the direction, right? So, so essentially, um, the component along this direction so this red line represents the direction along which I want to find the component, right? Given this direction, there is only one component, which is to find that I have to drop a perpendicular to the line, and then this vector is going to be the component, right? So to show this direction, I can give any vector I want that is along the direction, right? To show this direction, I can give any vector I want along the direction. I can give a vector of this much length, or I can give a vector of this much length, or I can give a vector of this much length. It doesn't matter. The only condition is that the direction that that vector is representing should be the same. Then the component of the purple vector is going to be the same, right? So in the previous question, I gave you I plus j in one case to represent the direction, right? In the second case, I gave you 2i plus 2j to represent the direction. Both of them have the same direction, right? Both vectors have the same direction. The component of the main vector, the purple vector, remains the same. Could I borrow some water? Thank you. So Alok, did you find it? Yeah? Wait. Did you find the component of A perpendicular to B?
Of A along B means we have to find the direction for that vector along B.
So you might want to rephrase that because that's not exactly what it meant by that. You have to find the component of A along the direction of B.
Okay. Direction of B.
Yes. So what is meant by rectangular component? Why are you not able to solve that? So what do you mean by rectangular components? Essentially, you split the vector into two rectangular components, which when added should give you the original vector, right? I taught you this. Do you not remember? If there is one vector like this and we divide it into two rectangular components, we resolve it into two rectangular components. One component will be like this and the other component will be perpendicular to it. When we vectorially add the two components, we should get the original vector, right? When we vectorially add the two components, we should get the original vector. So this component in purple, which is the rectangular component which is perpendicular to B, is simply going to be A vector minus A dot B B cap divided by mod B. So let this vector yeah, we'll see. So let this vector be C vector, okay? C vector is the Saeed, listen. C vector is the perpendicular component, right? So C vector plus A dot B into B vector B cap divided by mod B. What is this going to give you? This is the rectangular component perpendicular to it. This is the rectangular component along B, right? When you vectorially add them together, you should get A vector, right? Yes? Huh? Yeah, this is why I said it's getting heavy now, so you have to pay attention. Okay, we are still in dot product territory. We are still in dot product territory, so pay attention. I will start from the beginning. When you resolve two vectors, when you resolve two vectors, it is like splitting the vector into two vectors when added gives the original vector, right? In an equation, you can write 2a equal to a plus a, right? Or you can write 5x equal to 2x plus 3x, right? To maybe factorize or do some weird stuff like that, you can express something as the sum of two other terms, right? Likewise, you can express a vector as the sum of two rectangular components. You can take one component along any axis. Doesn't have to be the x-axis. Right now I have taken it along the x-axis, but it doesn't have to be the x-axis. You can take it along any axis and then another one perpendicular to that axis, right? If this angle is theta, if this, I don't care, shut up. If this angle is theta, this is going to be mod A cos theta, right? If this is A vector, this length is going to be mod A cos theta, this length is going to be mod A sin theta, right? And the angle between the two vectors is going to be 90 degrees because they are rectangular components, right? What do you get when you add the two vectors? You're going to get A vector, right? If you have two vectors like this which are perpendicular, if you have this is P vector and this is Q vector, what is going to be the magnitude of the sum of the two vectors? What is going to be the sum of the magnitude, what is going to be the magnitude of the sum of these two vectors given that they are perpendicular? This has P vector has magnitude mod P and Q vector has magnitude mod Q. Root of mod P square plus mod Q square, right? The formula that we learned earlier, except it becomes 2 mod Q mod P cos 90, right? Cos 90 is 0, so that term vanishes. It is just under root mod P square plus mod Q square, correct? Similarly, what happens when you do mod A cos theta the whole square plus mod A sin theta the whole square? Mod A sin theta the whole square plus mod A cos theta the whole square. You can take mod A square outside and inside it becomes, for example, mod A sin theta the whole square plus mod A cos theta the whole square will give you mod A square, right? Which is what we expect because these rectangular components should add up to the original vector. So we have a method to find this vector, right? What is that vector? If I tell you, if I have any vector along this direction and I say this is B vector, right? Any vector which is representative of that direction, essentially I want B cap, but I have some vector along that direction How do I find the rectangular component of A along B, which is this yellow line? What is it? Yellow vector, what is it? You already know. It is going to be A dot B divided by mod B times B cap, right? Right? This is going to be the same as A cos theta B cap, which is the vector we want. So this vector, which is perpendicular to it, the perpendicular component, let it be C cap, C vector, right? What is C vector plus this term? A vector. So how do you find the perpendicular component? So C vector plus A dot B divided by mod B into B cap will give me A vector, where this C is the perpendicular component. What? Yes, sorry, not A cap, not A cap. My mistake. What?
Why did B cap come there?
Why did?
B cap go there.
I mean, I've seen that one, so
So which part is confusing you?
B cap, how did B cap there?
V cap represents the direction along this axis, right? We want the component of A along B, right? Along B vector. So essentially, we want mod A cos theta B cap, right?
So what does it do?
I'm
No, why did we add C vector and that to find A vector? Why did we find A vector?
we're not trying to find A vector, we're trying to find C vector.
Okay, why are we finding C vector?
That is the question. That is the perpendicular component.
So we have to find the perpendicular component.
Yes. Hey, you clowns, did you understand? How many of you on that row understood? That, yeah, row, whatever it is, column, understood? All of you understood. You lot didn't understand? What about the people here? How many of you understood? Okay, why do I get the feeling that you're not listening? Too much of? Okay, let's try that. How many of you didn't understand on this row? Which part did you not understand? You there? What was your name? Yes. What is your name? Which part did you not understand? Yeah, there is only 20 minutes left, so we will learn this and then we will go.
Discuss all.
No. Okay. So, stop talking. Stop talking. Okay, I'm going to take this as a challenge. We are going to learn this and then we are going to get lost. Okay? So, which part did you people not understand? Did you understand, first of all, resolution of vectors? Did you understand what rectangular component is? What is rectangular component?
We have to find the vector. So we do
Yes. Yes. That's it. So listen, I will say one more time. If you have a vector, if you have a purple vector like this, now don't tell me if I change the color you won't be able to solve. Okay. If we have a purple vector which is the original vector and a certain direction, direction is this yellow line here, right? This is the direction along which I want to resolve the purple vector. The way you can write in an expression, for example, something like 5x plus x square, you can write it as 2x plus 3x plus x square, right? Like that, you can split a vector, stop talking, clown. You can split a vector into two rectangular components, right? So if there is a vector like this represented by the pen here, I can split that into two rectangular components which are perpendicular to each other, right? So if I have a vector like this is A. I can split it into two rectangular components like this, one along the x-axis and the other along the y-axis. Does not have to be x-axis and y-axis. If the direction along which I want to take the component is x-axis, then one direction will be x-axis, the other direction will be perpendicular to it. Need not even be y-axis, right? Okay. Now, yes?
explain that in a real life example. In a creative way.
So I think you should show it with the triangular thing. Like
With
show
the
how y and x will add up, how they are like rectangles.
So give me a vector. Give me a vector in just xy plane.
5i plus 6j.
5i plus 6j. All right. So this can be split. This can be split into its associated rectangular components. Now, if I want to split this along the x-axis and y-axis, if I want to split this along the x-axis and y-axis, what are the two components? 5i and 6j, right? So this is 5i and this is 6j, right? So the way we write things in terms of unit vectors is by splitting the vector into rectangular components. Do you understand? We traditionally do that in the x and y axes, which is why you have something like 5i plus 6j to represent a vector. You can also represent a vector in polar coordinates, which is you will give this particular length and you will give this particular angle. That is another way for you to represent a vector. But I am not going to teach you polar coordinates because you are completely screwed by the ordinary coordinates anyway. There are many ways in which you can represent a vector, right? One of them is in terms of rectangular coordinates, which is what you are being taught. But let us say we don't want our rectangular coordinates to be I and j, right? We want to resolve a vector like this, for instance, along this axis and an axis perpendicular to it, right? We want to resolve a vector along two axes which are not the I and j axes, right? So, one component is going to look like this and the other component is going to look like this. Our task is to find these two red lines, right, red vectors, which when added together gives us the white vector in the middle, right? How do you add these two vectors? You vectorially add them. right? Not their magnitudes. In order to find this vector here, we are going to call this mod A cos theta, where this is theta, and if this direction is given by B vector, if this direction is given to you by using B vector, then what is the direction actually? It's B cap, right? So this vector here is going to be mod A cos theta B cap, right? How do you find that particular vector in that direction? How do you find the component vector here? You need mod A. Can you find mod A if I give you some a vector in ijk components? Can you find mod A? For instance, I say I plus j plus k. What is the modulus? Is it root 3 or root 2? Root 3. Yes. You can find mod A. Can you find cos theta? How do you find cos theta? Eh? How you nodded without understanding the question. Can you find cos theta if I give you a direction and a vector? If I give you two vectors, can you find the cos theta between them? Yes, yes. A dot B divided by mod A mod B will give me cos theta. I have mod A, I have cos theta, I can find B cap. So I can find the component which is along B. Now, something is the component along the perpendicular direction, right? I am going to call it C vector. Now, C vector plus mod A cos theta B cap. What will this give me? A vector. That's it. Using this relation, I will be able to find the perpendicular component. Did you understand? How many of you didn't understand this time? What? How many of you did understand? How many of you did understand this time? Did. Did. D-I-D. Did. Not did he.